Hi everyone, I'm Santhosh Kumar from Sims Academy. In the previous session, we have dealt some numericals based on the work done by the constant force, and here we go with some more numericals in this present session. Okay, let us go on to the problem here. A force acts on a 30-gram particle in such a way that the position of the particle as a function of time is given by x equals to 3t minus 4t square plus t cube, where x is in meters and t is in seconds. The work done during the first 4 seconds is, okay, here we are given the position of the particle, that is x equals to 3t minus 4t square plus t cube, and the mass of the particle is also given as well, that is 30 grams. Let us convert it into kilograms, that is 30 into 10 power minus 3 kg, or 30 by 1000, 0.03 kg. Now, the work done during the first 4 seconds. First 4 seconds in the sense, okay, let us find the velocity first. Velocity equals to d by dt of x, that is the rate of change of displacement, that is d by dt of 3t minus 4t square plus t cube. As we know, according to the differentiation, d by dt of t equals to 1, d by dt of t square equals to 2t, and d by dt of t cube equals to 3t square. Okay, now here let us find the velocity 3. If I keep it outside because it is a constant, d by dt of t minus 4 into we have d by dt of t square, and plus again we have d by dt of t cube, that is v equals to 3 into 1 minus 4 into 2t plus 3t square. Now he asks us to calculate the work done in the first 4 seconds. Okay, v equals to 3 minus 8t plus 3t square. Let us find initial velocity. U can be found out at t equals to 0. That is v at t equals to 0 equals to 3, as 8 into 0 is 0 and 3 into 0 square is also 0. Similarly, let us find the velocity at t equals to 4, that equals to 3 minus 8 into 4 plus 3 into, we have 4 square, that equals to 3 minus 32 plus 4 square, it is 16, 3 is 48. 48 minus 32, it is 16 plus 3, we have got the final velocity as 19 meters per second and initial velocity as 3 meters per second. Now, according to the work energy theorem, according to work energy theorem, we have the work done on an object is equals to change in kinetic energy, that is half m of v square minus u square, that equals to half into m we have here is 0.03 into v square, that is 19 square, minus u square, that is 3 square. that equals to 1 by 2 of 0.03 of 361 minus 9, which equals to 1 by 2 of 0.03 into 361 minus 9. If I'm not wrong, it is 352. Okay. 2 ones, 2, 15, 2 sevens, 14, to 6, 176 into 3. Okay, let us calculate here. 176 into 3, 6 3 is 18, 7 3 is 21, plus 1, 22, 2 is remain, 3 1 is 3, plus 2, it is 5. Decimal should be kept between the two, before the two digits. Then we have the answer as 5.28 joules. That is our first option. I hope you people have got the clarity. Actually, we are given the position which is dependent on time. By using that, we found the velocity. Velocity is nothing but the rate of change of displacement. By using the formula of differentiation, we calculated the value of v in terms of time, and he asked the work done during the first 4 seconds. In the sense, the object is possessing some initial velocity here. That means when we have substituted the value of t as 0, we got 3 meters per second as the initial velocity, and the final velocity is 19 meters per second. According to work energy theorem, the work done on an object is equals to the change in kinetic energy, half m of v square minus u square. And by simplifying, we got the answer as 5.28 joules. Okay, now let us move on to the next numerical here. Next numerical we have is a particle is acted upon by a force of constant magnitude, which is always perpendicular to the velocity of the particle. The motion of the particle takes place in a plane, okay, two-dimensional. It follows that the first option, velocity is constant. Second option, acceleration is constant. Third option, kinetic energy is constant. And fourth option, we are given here as moves in a straight line. Okay, first of all, let us go back to the definition of work. Work is given by the dot product of force and displacement. That is Fs cos theta. Now, in this particular question, he's saying that the force which is constant, of constant magnitude, it is always perpendicular to the velocity. If the force is perpendicular to the velocity, then obviously the force is perpendicular to the displacement. As the velocity has the direction the same as that of the displacement. Hence, in this particular case, we have the angle between the force and displacement, theta equals to 90 degrees. When theta equals to 90 degrees, cos 90 equals to 0. That means work done is 0. When the work done on the object is 0, now again coming to work energy theorem. According to work energy theorem, we have work done on an object is equals to change in kinetic energy, which equals to 0. That means there is no change in the kinetic energy of the object. When there is no change in the kinetic energy, we say that kinetic energy is constant. Here, what the question is being given to us is that the force is perpendicular to the velocity. That's why we have considered as the velocity has the same direction as that of the displacement. Hence, we consider the force and displacement are perpendicular to each other in this particular case. Hence, the work done on an object is zero. According to work energy theorem, the work done on an object is equal to the change in kinetic energy. If the change in kinetic energy is zero, obviously kinetic energy remains constant. That is the thing. Okay. Let us move on to the next question here. Wow. We have come to a very beautiful question. The work done in pulling up a block of wood weighing 2 kilonewton for a length of 10 meters on a smooth plane inclined at an angle of 15 degrees with the horizontal ease. Okay, now we have to consider an inclined plane first of all. Let us consider an inclined plane. Okay. Okay. Here the object is kept. And its weight is given as 2 kilonewtons. Directly they have given us the weight. Okay, whenever an object is present on an inclined surface of mass m, let us say, then as we know, the weight of the object always acts downwards. The weight of the object always act downwards. Here the weight is mg, and the weight gets divided into two components. This is one component which is perpendicular to this inclined surface, and this is another component which is parallel to the inclined surface. Okay, inclined plane or surface, whatever it might be. And now what is it, what is he asking? The work done in pulling up a block of wood weighing 2 kilonewtons. That means the force is acting here upwards to pull this mass. In the sense, what are the components? If this is theta, this becomes 90 minus theta. As these two are perpendicular, again this becomes theta. Okay, and this is the side which is adjacent to theta. Adjacent to theta, the relationship is given by cos theta. Cos theta equals to adjacent side to theta by hypotenuse. Hence, the component that comes over here is mg cos theta, and obviously the other component is mg sin theta. That is equivalent to the force that is pulling the weight block of wood weighing 2 kilonewtons. Okay, now let us write the weight of this block, that is W equals to 2 kilonewton, in the sense 2 into 10 power 3 Newton, or we say it as 2000 Newton. That means W in the sense mg equals to, in this concept, 2000 Newton. Here, according to the free body diagram, we get the force that is pulling is F equals to mg sine theta. and the angle is also given over here, theta equals to 15 degrees, and even the value of sine 15 is also given as well as 0.2588. Hence, F equals to mg, it is 2000 into 0.2588. Okay, let us multiply 2588 with 2 here. Then we get 8 to 16, 16 plus 1, 17, 5 to 10, 2 to 4 plus 1, 5. Yes, am I right? Okay, let me check once again. This is 8 to just 16, 6. 8 to just 16 plus 1, 17. Okay, 5 to the 10 here. 16, 16 plus 1, 17. 5 to the 10 plus 1, again 11. 2 to the 4 plus 1, 5. Finally, we got the value of F as 5.176 newtons. This is our option B. In case of such kind of problems, if we take the free body diagram, it's very easy for us. Okay. And next, okay, let us move on to the next problem here. Particle of mass 100 grams, a particle of mass 100 grams is thrown vertically upwards with a velocity 5 meters per second, and he is asking us the work done by the force of gravity during the time the particle goes up is. Okay, first of all, whatever the given things, let us write over here. Mass is given, mass equals to 100 grams, in the sense 100 by 1000 kg, which equals to 0.1 kg. And it is thrown vertically upwards with a speed of 5 meters per second. Initial speed u equals to 5 meters per second. The work done by the force of gravity during the time the particle goes up, in the sense the particle has reached its maximum height here. At the maximum height, the final velocity of the particle is always zero. Now again, let us move back to the work energy theorem. According to work energy theorem, we have the work done on an object is equals to change in kinetic energy. That equals to half m of v square minus u square. That equals to half into m, we have 0.1 v square, 0 square minus u square, it is 5 square. Okay, 1 by 2 into 0.1 into, we have 0 minus 5 square, it is 25, we get minus 25. Finally, 0.1 into 25, it is 2.5 by 2, that is 1.25 joules. Minus. Why did we get minus over here? Because the minus sign indicates the work is done against the gravity. Got it? It moved, the particle has moved against the gravity. Hence, negative work is done over here. That is minus 1.25 joules. Let us see. Simple factor. Let us move on to the next problem. That is, okay, here we have got a ball. A ball is released from the top of a tower. the ratio of work done by the force of gravity in first, second, and third second of motion of the ball is first second, second second, and third second. Okay, whenever the ball is coming from the top, when it is released, yes, its initial velocity is 0. Okay, and it is coming towards the ground. Here we take acceleration due to gravity as positive, u equals to 0, acceleration due to gravity plus g. Here we can consider the work done is equals to the potential energy that is present with the object. According to the law of conservation of energy, the kinetic energy may change into potential energy. The potential energy may change into kinetic energy, but the total energy, that is the sum of potential energy and kinetic energies of the object, always remain constant. Okay, let us find the potential energies of the object over here. That is W equals to mgh in the first, second, and third second of motion of the ball. Okay, f nth second formula we have, it is u plus a of n minus half. As u is 0 in this particular case and a value is g, then we take n minus half. Now, the displacement made by the object in the first second, let us say it as h1. First second equals to g of 1 minus half. We have full minus half, half. That is g of 1 by 2. S second, that is h2 equals to g of 2 minus half. That equals to g of 2 minus half. 2 to the 4 minus 1, it is 3 by 2. And as third second, let us say it as h3. G of 3 minus half. 3 to 6 minus 1, it is 5 by 2. Now we are asked to find the ratios of work done in the first second is to second is to third second. Now work done in the first second equals to mgh1. Second equals to mgh2. And third second equals to mgh3. Let us substitute those values over here. mgh1 is to mgh2 is to mgh3. mg gets cancelled in all the three things. h1 we have as g of 1 by 2. h2 we have as g of 3 by 2. And h3 we have as g of 5 by 2. G gets cancelled. 2 gets cancelled. Then finally we got the ratio of work done in first, second, and third second of motion of the ball as 1:3:5. Here is our option C. Got it? Here we used Snth formula. Snth is u plus a of n minus half. As the object is released from the top of the tower, initial velocity is 0. As the object is coming towards the ground, we take the acceleration as positive. Hence A equals to plus G, and we calculated and simplified that. Let us move on to the next one. Next problem we have is here the man, Superman, I think. Let us see that Superman. A man starts walking from a point on the surface of the earth, assume smooth, no friction, okay, and reaches diagonally opposite point. What is the work done by him? Okay, that means this is our earth. The man from this point A, let us assume from this point A, he reached exactly the diagonally opposite end, he is saying. This is the center of our earth. Let us say man has started from the point A and reached to the point B. Now, whenever he is moving, he is under the influence of the gravitational force. As we know, the gravitational force is a conservative force. Okay, let us think in different manner. Okay, suppose the man has come from A to here. Then let us say the work done is R be the radius of the earth, mgr. Then when he moves from O to B, he is doing the work against the gravity. If suppose if he is coming from A to here, this end, he is coming towards the gravitational pull, then it implies when he moves from this point to B, it indicates he is moving against the gravitational force of our earth. Hence, the work done is negative. Now, what is the total work done over here by the man? mgr minus mgr, W equals to 0. Hence, there is no use for a man walking from the surface of the earth from a point to diagonally opposite end according to the physics. But what happens if we walk originally? Just imagine. And here our option is A. I hope you understood this. Gravitational force is a conservative force. For a conservative force, let us conservative force, the work done in the round trip is always 0. Round trip is 0 anyway. Here is it is positive, then it becomes the negative one. Okay. Let us see the next problem. Next problem. Oh, the energy which here the answer is in the question only. The energy which an electron acquires an acceleration through a potential difference of 1 volt. Electron has got a potential difference. It has been accelerated with a potential difference of 1 volt. That is nothing but electron volt. Directly it is given. Electron volt. Electron volt. Very simple question. And let us move on to the next one. Next one, here we have the area of the acceleration displacement curve of a body gives. First option we are given is impulse. Second option, change in momentum per unit mass. Third option, change in kinetic energy per unit mass. Fourth option, total change in energy. Okay. Now, for area of a rectangle, length into breadth. That means if we have a product, we can get its area. That's it. Okay, let us take that one as a basic concept for our question. Let us say this one as displacement, and y direction, let us take it as force, and displacement and force, sorry, acceleration, right? Okay. This is acceleration. This is acceleration, displacement curve, or whatever it might be. Okay. Whenever the displacement is going on, the body is accelerating. Let us say the area that is covered gives what? This is the question. L into B is the area. Okay. Let us go on to the concept now. The work done on an object is given by the product of force and displacement, but according to the second law of motion, Newton's second law of motion, we have the force as F equals to mass into acceleration. And according to work energy theorem, again here, work energy theorem, the work done on an object is equal to change in kinetic energy, that equals to F into S. F into S, that equals to change in kinetic energy equals to M into A into S. Let us divide the entire equation with M. Then we get change in kinetic energy, sorry, by M we are dividing. Then we get MM gets cancelled and A into S. If there is the product, we get the area. That means the area under acceleration displacement curve gives us the change in kinetic energy per unit mass. And here is the option. Yes. Let us move on to the next one. Next one. Next one. Oh, a body of mass 10 kg at rest is simultaneously simultaneously by two forces, 4 Newton and 3 Newton at right angles to each other. The kinetic energy of the body at the end of 10 seconds is. Okay, let us see. The mass is given as 10 kg. Here, the forces F1 is given as 4 newtons and F2 is given as 3 newtons are acting at right angles. Theta equals to 90 degrees. Now, according to the parallelogram law of vectors, F equals to under root of F1 square plus F2 square plus 2 F1 F2 cos theta. If theta equals to 90 degrees, then cos 90 equals to 0. Hence, we get f equals to under root of 3 square plus 4 square, or 4 square plus 3 square, whatever it might be. 4 square plus 3 square, that equals to under root of 16 plus 9, that equals to root 25, which equals to 5 newtons. Now we got F as 5 newtons, and mass is given as 10 kg. Kinetic energy at the end of 10 seconds. Now, initially at rest, he said that is u equals to 0. And time is also given, t equals to, that is 10 seconds. Now, the other important thing in the equations of motion, in 4 equations of motion, 2 parameters are compulsory. One is initial velocity and the second one is acceleration. How should we find that acceleration? Now, according to Newton's second law of motion, we have F equals to ma. F equals to m into a. From this, we can write a equals to f by m. F, that is 5, by m we have 10. We got the value of s of meters per second square. A equals to 1 by 2 meters per second square. Now what are we supposed to find? Let us find the final velocity. From the first equation of motion, we have v equals to u plus a into t. As u is 0, a into t, half into 10, that equals to 5 meters per second. Now we got the final velocity. We are given the initial velocity. That means the object is at rest. Hence, according to the work energy theorem, we have the work done on an object is equal to the change in kinetic energy. That is half m of v square minus u square. That equals to half m, it is given as 10 kg, v square 5 square minus u square 0 square. Okay, let us cancel this one. Finally, we have 5 this is 5 into 5 square, we have 25, and 5 into 25 is 125 joules. That is your answer. Problem is very nice. 2 forces are acting. Okay, let us go on to the next problem, next and final problem for today. That is man climbing. Why does this man climb unnecessarily? Okay, let us see. Here the question is a 50 kg man. M equals to 50 kg. Okay, got it. With load, okay, man mass m1, let us take. Load is also there, 20 kg. Now total mass is m1 plus m2. That equals to 50 plus 20, which equals to 70 kg. Now, what is it doing? On his head climbs up 20 steps of 0.25-meter height each. Each means each one h1 equals to 0.25 meters. He climbed 20 steps. That means how much is the total height he reached? H equals to 20 into 0.25. This decimal comes over here. 2.5 into 2, it is 5 meters he climbed up. The work done in climbing up is, okay, W equals to, in this case, potential energy. Yes, W equals to mgh. M, it is, we have 70, and G, he did not mention. Okay, let us take it as 9.8 into H, it is 5. Then, okay, let us cancel this point and 0. 7 5 35, 98 into 35, 8 5 44 aside, 9 5 45, 8 3 is 24 plus 4 28, 28 plus 45, 33, 73, 3 7 remains aside, 9 7 9 3 27, 27 plus 7, it is 34. This is one step multiplication, which I explained in my channel previously. You can go through it if you need it. And our final answer here is 3430. The work done on climbing up 20 steps of 0.25-meter height each by a man whose weight is 50 kg with 20 kg load on his head. Total it is 70 kg. W equals to mgh. We got it as 3430 joules. Okay, and today we had a very good session. Yes, and in the next session, we are going to learn about the force done by a, the work done by the variable force. By that, this is Santhosh Kumar signing out from Sims Academy. Bye.